Today we're beginning section 1.6 in your textbook, and the name of the section is solving for a variable. But this is going to look a little bit different from solving for the variables in equations that we solved for before. We're not going to get numerical answers. In other words, you're not going to get something like x equals 7 or n equals -5. You'll see what happens as we solve these variable formulas. Now, I want you to look on page 49 in your book and find the definition of a formula up near the top. I'm going to pause for a moment while you write down the definition of a formula on a piece of paper that you will turn in tomorrow. So on page 49, a formula is, write that down on your paper, please, and complete that statement. The first formula we're going to look at is one that should be familiar to you. Distance equals rate times time. We know that when you are, say, driving a car, if you know how fast you're going, say 50 miles per hour, and you know that you've been driving for, let's say, 2 hours, you can calculate that you've traveled a distance of 100 miles. Now, if you think about that, that just makes sense. Distance equals rate times time. But let's say that you've been driving along at a steady rate, and you realize that you have a distance left to travel, and you want to figure out how much time that will take. Think about this. If I know what the distance is that I need to go, and I know the rate of time, but I want to find out how much time, I'm sorry, I should really say the rate of speed there, then I could rearrange this formula this way. Distance divided by rate equals time. Now say that I needed to drive to Atlanta, and Atlanta is 300 miles away. And let's say that I know that I'm going to go about 50 miles an hour. Yes, I drive slow. Well, then I know it would take me 6 hours to get to Atlanta by using the distance, rate, and time formula, but rearranging it. That's what you're going to be doing in this section. All right, I'm skipping example 1 and 2. Example 1 was about distance, rate, and time. Please read it. We'll come back to example 2 because it's a little more complicated. I want to start with an easier one. Example 3 is just a short equation. M minus n equals 5. And you have to be told what to solve for. I would not just give you an equation with more than one letter in it and say solve it. In this case, I'm going to say solve for m. Just like before with numerical equations, you look at the equation, you think about what part you want to solve for, you think about what's happening to it. In this equation, what's happening to m is something is being subtracted from it. That's the only thing that's happening to m. So if I want to get m by itself, just like before, I do the inverse. And the inverse of subtracting n is to add n. Now when I do that, I'm not going to line up the 5 and the n. The reason is they're not like terms. Just like before, 5 is a constant, n is a variable. They can't be combined into one new term. But I can certainly write m is equal to 5 plus n. You're finished when your variable that you're solving for is standing by itself with a coefficient of 1. Everything else is on the other side. What's different from before is now what's on the other side is not just a number. It's going to have numbers, variables, and maybe some operations over there also. So let's get this out of the way. I am now at the bottom of page 50, or underneath example 3, looking at the check it out problems. You should write down example 3, pause the recording if you need to. Have that ready to turn in tomorrow on that same piece of paper. Okay, now let's do the check it out problems. I'll draw a line here so you can see there are two different ones. 3a says 5 minus b equals 2t, and we're solving for t. Now once again, make your eyes look for the variable. Wherever you see the variable, take note of it. Well, there's the t that we want to solve for. The only thing happening to t here is that it's being multiplied by 2. That's the same as saying it has a coefficient of 2. Now when I say that means we're going to divide by 2, don't get carried away. You don't have to actually carry out any division. In fact, some people like these better because they say, hey, these are less work. If I had a number over there that I had to divide by 2, I'd actually have to do some division. All you're going to do in solving the formula is rewrite the formula a new way. So I'll still have 5 minus b, but divided by 2. That isolates t, gets it by itself. That's all you can do for that one. Formulas can be longer and more complicated, but most of the examples you're going to look at are not very long. All right, 3b is an actual formula. I believe it's distance equals mass times velocity. I could be wrong about that. I'll ask the science teacher. But if we're solving for b, this might not look very straightforward to you, but I'm going to do this in 2 steps. If I want to get b by itself, remember how we had problems where you had the variable divided by a number? Well, that's fine. We would multiply both sides by whatever that number is. So I'm going to multiply both sides times b. Now, that's not going to get the variable by itself yet. Here, I'm going to write this way, so now it looks like d is a coefficient. The b's over here cancel out, leaves you with m. And to get b by itself, divide by that d. Once again, don't get carried away. When I say divide by d, you can't say n divided by d is some number. But you can rewrite the equation so it's in this order. Some people say, well, okay, then that you mean the d and the b just switched places. Not exactly a mathematical way to explain it, but it does look like it worked out that way. All right, here's another example. And for you folks who like to say, well, where am I ever going to need to know this in real life? Or what is this all about? What meaning does it really have? This equation is one to calculate the initial velocity of an object, I for initial velocity. In other words, when you start moving an object, how fast is it going? F is for the final velocity, G is for the force of gravity, and T is for time. So think about this. If I throw, let's say, a dodgeball at someone, and I throw it very hard so it's going really fast, eventually what happens? I throw it, and the harder I throw it, the longer it stays in the air, but then the force of gravity brings it down until it stops. So that's what this formula is used to do. All right, so this we're instructed to solve for t here. So once again, I ask myself, what is happening to t in the equation? It's being multiplied by g, and it has another letter, f, being added to it. All right, so we're going to go in reverse order of operations, just like we did for a 2-step equation. If we were solving for t and we had a number here and a number here and a number for a coefficient here, the first thing we would do is subtract the f, right? Well, I'm going to subtract f. Leaves me with equals g times t. but I don't have to actually do any arithmetic. I don't have to carry out that subtraction. Now I'm looking at it as my variable t has a coefficient g, and what's the last step in solving an equation? Divide by the coefficient. Once again, you can't really carry out the division operation. This just means if you knew an initial velocity for an object and its final velocity, and you could account for the force of gravity on it, that's actually a constant that you'll learn about in science class, then you would be left with finding the time that that object was in motion. So there's a real-life example. All right, here's another real-life example. The circumference of a circle, 2 pi r. We know that 2 and pi are just numbers. Pi is not a variable. We know what it stands for. It's an irrational number, but it's still a number. If you want to get r by itself, and 2 pi r means 2 times pi times r, just divide both sides by 2 pi. And you can just write the formula that way. I always like to rewrite it so my last step is nice and clean with the variable I've solved for by itself with a coefficient of 1. We're going to look at one more example. I'm going back to example 2a on page 50 because you're ready now. It does have a fraction in it, but that's okay. Since you don't have a calculator at home, I'll take you through this one, and it's worked through in the book. But pay close attention to what happens here. We're solving for C, which means temperatures in degrees Celsius or centigrade. F is for temperature in degrees Fahrenheit. So this formula says that if you take the temperature in degrees Celsius, multiplied it by 9/5, and added 32 to that number, you would convert the temperature to degrees Fahrenheit, which is what we're more used to using. Well, let's suppose I needed to go the other way. If I knew the temperature in degrees Fahrenheit and I wanted to convert it to Celsius, here's how you could rearrange the formula first. All right, I look at what's happening to C, the variable I want to isolate. It has a coefficient of 9/5, and 32 is being added to that term. So using reverse order of operations, subtract 32 from both sides. Now remember, F is a variable, 32 is a constant. You can't actually join them together and combine them into one term, but you can definitely write F minus 32. That just means subtract 32 from the temperature in degrees Fahrenheit. Now, when your coefficient is a fraction, if we were just dealing with numbers here, we could definitely say, okay, well, I will just take the number and divide it by 9/5 using the TI inspire. In your book, they don't really think about having the TI inspire, so instead, they're reminding you that to get rid of a coefficient that's a fraction, you can multiply by the reciprocal. Multiplying by 5/9 is exactly the same as dividing by 9/5. And whatever you do on the left, you have to do on the right. But there's one more thing to remember. If we're multiplying 5/9 times everything on the left, and we are, put that F minus 32 inside parentheses. That's the only way it'll work. And I'm sorry it's a little crowded up here, but I think you can see what we have. I'll make it a little better. And that means that you can see, let's see how they did it in the book. You should be looking at the top of page 50 also. Yeah, the easiest way to write it is just like this. 5/9 times F minus 32 equals C. Because these two fractions cancel each other out, leaves you with a coefficient of 1, just like you want.